Hi, this is Dominic. This video serves as a first introduction to Dbux. We are first going to talk about what Dbux is and where it came from, and then we are going to jump right into the action and look at how Dbux works in two examples. The first example is going to look at a nice and simple piece of code, and the second example is going to take us into a real-world bug that actually happened in the Express repository a few years ago. You can find timestamps below the video if you want to skip ahead. So what is all of this about? I thought of Dbux in October 2019 when I was working on a piece of front-end code, and I just spent another 20 to 30 minutes on a bug. And it did not make a lot of sense to me that I would spend all this time on such a relatively simple bug. I felt that the tools that I usually used, that being the traditional real-time debugger, as well as, a lot of console log, were failing me. It is actually quite a lot of effort to just find out something very simple about what our programs are doing. It feels like these tools are not helping us to really get to the bottom of things. We are really not so aware of what is happening to our own programs while they are executing and all the things that they do and all the values that they generate. The idea is that Dbux would just record everything our program does. It would then take that data, send it to some server, where we do a little bit of preliminary data analysis and then present all the refined data in a UI and visualize and make interactive the runtime of our own programs. Our first example is this very simple algorithm with a bug in it. We can run it with Dbux enabled through this button over here. There we go. And we can see all kinds of console output, but we can also see this little thing down here, test failed, that came from the program itself. Let's close this down. We can see test failed coming from here. And the interesting thing is we know that this executed even without looking at the console output because of all the code annotations that have now been added. The beautiful thing about all the data that we have is that we can actually easily annotate the code and show exactly what parts of our code has executed and what hasn't. We know that this part executed, but this is only a symptom, a visual manifestation of our problem. We now need to actually go and trace it down. The first thing that we can do is we can go up maybe to here. We can see that this if condition certainly plays a big part in all of this. It must be true in order for the test to fail. So we can look at this one and we can then select the trace of that execution of this piece of code. And such a trace shows us all the data related to what happened when we executed this piece of code. For example, the value of this, which is actually an expression, is true. And of course it must be true because else we wouldn't end up in this branch. We also know it executed exactly one time. All right, and the next thing that we can do is we can now retrace exactly what happened during the execution of our program by using these buttons over here. We can, for example, go back one step and go here. And then we can take more steps and we can go in both directions, forward and backward. Looking at our if condition down here, and we can again select these values over here, we can see that the actual value is an array over here, and we can now actually inspect it. We can go open this up and we can see 4513, an array with 4513. However, our expected value, as we can see right here, is actually not that. And we can also see that by selecting this guy and looking at the value over here. Yes, it certainly is not equal. Makes sense. We can now trace the source of this array and how it came to be. And there are several different ways of doing that. We can take a step back like that and keep going back, and we are here, and we can see that the largest array function, which is the actual algorithm over here that generated this array, has been called here. And we again see that the resulting value of this call expression is of course our faulty array 4513. And we can now step into that by using these step into buttons either to the front or to the end of that function. We're probably interested more in the last trace of that function. And there we go, and now we are in the function. And we can keep going, we go up one, and we can see that the return statement over here again shows our faulty array, just very much like we would expect. Let's take a look at this function. There is some sort of initialization over here, there is a for loop over here, there is an if statement, and then there is an assignment over here. And the assignment is the only place inside of the for loop where something's actually supposed to happen. However, it never got executed. There's no annotation on it, and when we try to select it, it would say no traces at cursor. This line never got executed, meaning that the if condition above never was true. So let's look at this condition over here. We can again just click into it and select it right away. We can also use navigation to get here. Either way works. So when we select it, we see that its value is false. Now the thing is, it's a loop, and that means we have executed it multiple times. In fact, we have executed it 3 times. And if we open this up, we can see that every time it was false. Of all the 3 times that it got executed, every time it's false, false, and false again, meaning that we were never able to do the assignment here, which again seems to be the main workload in this program. So how did that happen? We can now go and just select the left and right hand side of this expression and investigate them individually like this. And again, we can see that it got executed 3 times. The first time it got an input of an array 4513 and the output was 5. The second time we have 1000, 1001, 857, 1, and the output was 1001. And so this is all making a lot of sense. It takes in an array and gives us the max value, which is exactly what we would expect of this call. And then we can compare it to the right hand side here, over here, and we can select this guy over here, select, and we can see that, oh, well, this time, every time we pass in the 4513, which is the first array in our input, and it's returning null. And then it might dawn on us that this is certainly not what we would expect, and in all likelihood the problem is right here. And even if we are not too familiar with ES6 syntax, at this point we are much more likely to investigate and figure out what happened here. And of course we forgot the weird triple dot, which, well, admittedly is maybe not the most intuitive way of using math.max of any programming language ever invented. So here we go. We then we can now just run the whole thing again. And this time, I hope everything passed. We saw this did actually not execute. This means that this is equal has a value of true, and the overall if condition is false. This was our first look at how to use Dbux. Let's now move over to a real-world example in Express. In the second example, we are looking at a bug that actually existed in the Express repository a few years ago. In order to reproduce the bug, we are using Mocha to run a test that will fail. We are telling Mocha to run this specific test file, and within it, we are looking for one specific test that's going to pertain to this one specific bug. Now, I already executed the whole thing. I ran it with Dbux enabled, and as a result, we can now see, this is the test file itself, that we have all the annotations already there, and now we can start to dig. So the test itself is right here. Should only include each method once, specifically options should only include each method once, and it's failing. And now we can bring this up a little bit and look at the result of the test run right there. So it executed the test right there, and it failed. And we see that the error is this: expected get put, but got get put get instead in our response body. We specifically want to approach this as someone who has no experience in the Express source code itself. However, at the same time, in order to debug these kinds of things, of course, it would certainly be very helpful to have a basic understanding of how Express works and how HTTP works. But knowledge of the code base itself is absolutely not necessary, and this is what this is all about. How do we actually work with a bug, or how do we debug something in a code base that we are not very familiar with? Let's see. This is the expected and the actual result, and we can look down here. And this is the test that produces that result, and we can now connect the dots. So we are getting we are expecting a get put right there, but we are getting a get put get. We are getting that from sending an HTTP options request. The options request, according to the HTTP spec, will tell us all the verbs that are associated with a route. So we have a route here, which is the user's route, and the options should tell us all the verbs, all the options, I guess I'm using these words synonymously here, that have been associated with this route. If you ever have used fetch, or if you have used express, I'm sure you have seen it before, get and put, certainly often being used. We are actually registering 3 routes. One get, one put, one get. Now that would probably explain why we see that down here, get, put, get. However, according to the HTTP spec, each verb should only exist once. So that's what we need to find out. We need to find out in this code that we have never looked at before, where are we generating this outcome, and how can we fix it such that we would get the expected outcome. All right. So traditionally, what would we do? We would first of all, I guess, look at the files. So if we look here, that's the Express folder right there. Inside of it, this is the code. It's actually not that big. Express only has a few thousand lines of code. Now, this is one way of doing it, looking at the files and then going from there. Another way of looking at it is using the search option and go and look for specifically the keyword that we are looking for is probably options. I would probably put that here. In all the files, I would look for options and try to narrow it down and then go from there. That would maybe be the traditional way. But in case of Dbux, we have already run the program once and that's it. We have all the information we need. And we can now work against the runtime data that was generated and possibly narrow down the search. At least that would be my hope. The first time I approached this bug, I tried to use the same method that we used earlier in the first example, that somehow this thing here would generate the outcome. And then we can just use our navigation tools to kind of like step into this and then find how the outcome came to be. However, the problem is that we can see this from these gray arrows here, that this is actually not how it happened. This actually only called some library code, which then later on will produce that outcome that is not directly connected to this function call. So that might not be the way to go. We can instead maybe start by looking at, I'm gonna close this down here, look at our map. That is our dynamic call graph. The dynamic call graph here is now rendered. It basically shows us all the function calls and all the invocations of JavaScript files throughout the entire execution of the program. We'll see that the first thing usually is the entry point of our program, which is this test file right there. And if we click into it, it takes us right there. We can also search the call graph. We can use the search function to look for all the functions that have been executed. And because we're looking for something related to options, so let's just try that. And let's go. So now everything is kind of grayed out. However, all the function calls and all the file invocations that match the search have been highlighted. The first thing that we see is the app options.js. That's the test file right there. That makes sense because options is right there in the name. Let's look down below. Maybe we can find something else. So we go down and down and down. Everything that has the options keyword in the name will be highlighted. So as we can see, there's stuff happening right here. As you can see, the whole call graph is kind of like moving off to the right. And that is because this call graph is very deep. We can press the slim mode here and make things a little bit more compressed. That's kind of nice. Saves us a little bit of space. And then we can see that, oh, there's 3 function calls right there that have been highlighted. Now, if we look down below and go up again, yeah, that seems to be it. These 3 function calls that also all have the same color, by the way. Colors don't really matter all too much. It's actually it's terrible coloring here, but it is helpful in that all nodes of the same color are the same function, meaning that these 3 are probably all coming from the same function. Looking at the location here, it seems to be all the same function. All right, now I can click into it and it takes us right there. We can see that it returns something. Let's move this over to the right a little bit, and I can apologize for my small screen. I like to make everything a little bit bigger, but that means I have a lot less space here to work with. On the normal screen, this works actually quite nicely. I see the return value here, and I also see that the options call seems to be side effect free. It doesn't seem to do anything other than returning this thing. So I can now just use our tools here, just inspect this thing, select this trace, click a few times until it selects the whole thing. And now this is the return value. And then I can go here, go to value, and I see it's returning an array containing the string get. And that is, of course, only the first invocation right there. It's highlighted over there. I'm now going to remove the search, and that shows this colorful call graph right there. I'm going to go into sync mode, so it's just going to move with us as we move through the code on the left-hand side. And we see that return value being an array containing the string get is right there, and it's side effect free, which means we are probably not so much interested in this function per se, but we are probably interested in whoever is calling this function. And we can now use these navigation features right there. We can just step out like that. We go to the beginning of the function, we click it again, and it steps out. And this is where the function got called. And here, that's certainly interesting. It's now becoming part of this bigger thing right here, where we are trying to push something. We are trying to push the array that contains the word get. Again, this is the same value as the return value because that's how called expressions work. It tries to push that into something. The push keyword, we don't really know what's happening here, but we can, judging from the push keyword, we can assume that we are trying to move this or push this into an array. And so the options thing here seems to be an array. Let's select that. And yes, that is exactly what it is. It is an empty array. And you might be thinking, well, why is it an empty array? We are just pushing this array containing the get key, the get string into it. Shouldn't it contain like the get keyword somehow? And the reason why that is not the case is because this trace has been recorded before the push happened. That is why it's still empty. And after the push has succeeded, it would then contain the get string. However, we are not able to see that right here. Dbux right now only records the values of expressions that were executed. Later on, maybe we add some more features to keep track of the value of variables after certain operations have happened, but that's not the case right now. So we can now inspect the options array, and we can do a little bit of tracing there. We can specifically look at all the traces that involve this specific object. So we open this thing, and here we see now a list of 9 different traces. These are all the traces in all of the executed code where this options array was used. When we look at the object traces, usually the first thing that we see is the creation of that object. And that is, of course, only if the creation of that object is in the recorded code. However, sometimes things get created in some library and we would not see it. But if our code is creating this object, then the first trace here would always be the one that creates it. Or in case of a constructor, sometimes it's the this keyword inside of the constructor and so on. We see that here the options array got created, and then later on it's used to push in the first option there, which is again the get option. And then we can keep going and look at the next trace. Oh, that's right there. So it's this options push apply thing. That certainly makes sense that we have 2 traces right next to each other, doing kind of like not giving any extra info. And then we go down to the next one. Oh, that's interesting. It's the same place. However, it is a different execution of the same piece of code right there. As you can see, this piece of code got executed 3 times. And then we can go up again and we see, okay, this guy was empty. Then we pushed get into it. And then the next time we see it, oh, it got get inside of it. Great. And then the next time we go to the same trace here, it got get and put inside of it. And then the next time, well, the next time we will probably not see it again here because it only got executed 3 times. This is the 3rd time that's happened. The next trace that we look at is probably going to be somewhere else. And we can obviously also see that from the location here. This was in line 210, while the next time it's going to be in line 154. As you can see on the right-hand side, the call graph also just rapidly moved into some other place here. So this trace doesn't seem particularly interesting. Let's move ahead. And this is the last time we see it. And ooh, this certainly looks very good. So here we see all the options being joined together by a comma, and let's see what the result of that is. Okay, and we see object traces is now actually looking at this particular string, and we can trace that through the code. I'm just going to close that down for now. And we look at the value get, put, get. That's exactly the thing that's coming out here. So in all likelihood, that being called body and this being the exact same value that was produced over here, that seems to be the problem. That seems to be the bug right there. We got the options, but we didn't get a unique set of options. We got all of them. So this seems to be the end of our journey. Dbux helped us basically in 3 steps to trace this down. First of all, we searched for related functions. Then we did a little bit of tracing in the vicinity of the functions, and we came across this options object, and then we traced it all the way down here. And here we are with the exact result that we don't want to see. All we is left to do is to fix the bug. I guess in order to have the options being unique, I guess we can do something like this. This would certainly create a new array with the original array, but every element only existing once in it. And then we can rerun the bug. I'm going to use this very handy little tool that we're still developing that allows us to very easily use Dbux on these sorts of real-world bugs. We're gonna let it run, and we're done. We got the congratulations, the test actually passed and everything is good. And that is it. That concludes our brief introduction to Dbux. There's so many more features to talk about, but this will conclude our first video. I hope this was helpful. Feel free to check out the documentation, join us on Discord, leave us any sort of message, commentary, what have you. Thank you.